So in the last class, we are discussing about the simply supported beam with a point loads, and a UDL, that is uniformly distributed load. Uniformly distributed load applied on it. So we are drawing the shear force diagram and bending moment diagram for the simply supported beam, having an UDL, uniformly distributed load, entire span of the beam. So if you see here, the beam having an UDL, a beam having a UDL of W, small w, entire span, that is entire length, the load is applied. And we need to find out the reaction force RA and RB. We need to find out the reaction force RA and RB initially. After finding the reaction force, I need to find the shear force variation along the length. Shear force along the length. And I need to draw the shear force diagram under the beam using a pencil and a scale. So if you see the shear force diagram, it changes its sign. At some location. It is changing its sign from positive to negative. So I don't know the location. Therefore, I need to find out the x value. That is the location where the sign change occurs. I need to find out the location. From B, I need to see that location. So from the graph, that is shear force diagram graph, I am observing that it is touching the baseline. That means the shear force is equal to 0 at that location. The shear force is equal to 0 because it touches the baseline. Therefore, equating the shear force at that location, therefore I am considering this as C. Location. Therefore, I don't know the x value here. That is the length I don't know initially. Therefore, I am considering as x. Therefore, we have two forces, RB, which is moving upward direction, and a UDL. Whose length is x. Unknown value is x. Therefore, W, small w, L by 2 is the RB value. And if I convert this UDL into point load, I will get a point load whose magnitude is W into X. W into X is the magnitude on my right hand side of my section. This is the point load. I converted the UDL into point load now. I have converted the UDL into point load. Therefore, two point loads RB, which is moving upward direction, so it is a positive value, and W, capital W, which is moving downward direction, which is equal to 0 because the at C, we are observing that it is 0. It touches the baseline. Therefore, finding the x value, therefore x will be equal to L by 2. X will be equal to L by 2. Now I need to find out the bending moment at C also. We have 3 points now. A, B and C. 3 points are available now. So at C also I need to find out the bending moment. At C also I need to find out the bending moment. At B it is 0. Because if you see, observe the equation, bending moment equation. So it is in terms of x. So substituting x is equal to 0. That is at B. So substituting x is equal to 0, RB into 0, capital W into, again x is equal to 0 becomes 0. Bending moment at B is 0. And next point will be C. So after B we have a C point. Therefore the bending moment at C is, therefore substituting x is equal to L by 2 in my bending moment equation. Substituting x is equal to L by 2 in my bending moment equation. I will get WL square by 8. So that is the bending moment at x is equal to L by 2. At C, WL square by 8 is the bending moment at the C. And substituting x is equal to L. That is at A. Substituting x is equal to L at A. Therefore, again I will get the bending moment as 0. Therefore, I need to draw the bending moment diagram like a parabolic curve. By a free hand. Whose height of the parabolic curve is WL square by 8. So it is very important. Next problem. So here read the problem once. A simply supported beam 6 meters long, that he had given the span of the beam, and it is nothing but a simply supported beam, is carrying a UDL, uniformly distributed load, of 5 kilonewton per meter over a length of 3 meters from the right end. So here he had given the beam, length of the beam is 6 meters. So I need to draw the beam with 6 meters. And it is a simply supported, means both ends are having a two supports. Next, a UDL is acting on the beam. And whose magnitude is, that is small w value is 5 kilonewton per meter. And the length of the UDL is 3 meters. UDL must be act only 3 meters. So he had given that it begins from the right end. Therefore, this is the left side and this is the right side. Therefore, the UDL need to be begin from the right end and it need to be up to the 3 meters. It need to be up to the 3 meters and whose magnitude is 5 kilonewton per meter. 5 kilonewton per meter. So always they may give in a explanation point of view also. The question may be, they will not give any figure. You need to read the problem and you need to draw the figure and we need to follow the whatever he needs to find. So he needs the shear force and bending moment diagrams under the beam and also calculate the maximum bending moment under this section. So ఎప్పుడు డయాగ్రామ్ అంతా ఇచ్చేసి బీమ్ డయాగ్రామ్ అంతా ఇచ్చేసి దాని మీద ఏ లోడ్లు యాక్ట్ అవుతాయి అనేది ఇవ్వడమ్మా ఒకసారి. సో యూ నీడ్ టు స్టడీ ది ప్రాబ్లం, యూ నీడ్ టు స్టడీ ది ప్రాబ్లం అండ్ we need to visualize the actual problem and we need to draw the problem and we need to solve what we need to find here. So this is the problem here given. So this is the drawn, that is he is not giving the problem diagram. He is not giving the problem diagram. You need to draw it. You need to draw it, Amma. So here two unknowns RA and RB need to be calculated. RA and RB need to be calculated. Therefore, I have converted the UDL. I have converted the UDL into point load whose magnitude is capital W and it is equal to the 5 into 3 because 5 is the height of the UDL and 3 is the length of the UDL. 5 is the height of the UDL and 3 is the length of the UDL. That gives the area of the rectangle. And it is acting at a distance of 3 by 2 from C. From C 3 by 2 and from B it is also 3 by 2. At the center the point load will be acted. Therefore we have three unknowns now. 3 point loads only is available. First one is RB. Second one is a point load, external point load, and the third one is RA. Only 3 point loads are available in my beam now. Therefore, equaling the conditions, considering the equaling condition on the beam, therefore upward moving forces need to be balanced by the downwards moving forces. Therefore, here RA and RB are upward moving forces and 5 into 3 is a point load which is moving downward force. So this is the first balancing equation. We will call it as equilibrium condition. Second equilibrium condition is the couples, that is clockwise couples need to be equalized by the anti-clockwise couples by considering the bending moment at A. Bending moment at A is equal to 0. The net bending moment at A is equal to 0. Therefore, I need to consider a section at A. I need to consider a section at A. So here I have two forces and it's a perpendicular distance. Therefore, RB having a perpendicular distance as 6 meters. Therefore, RB into 6. Next, another point load W. Another point load W. It having a distance of 3 plus 3 by 2. 3 plus 3 by 2 from A. I need to consider from A. the distance from A to the each and every point. Therefore, W into 3 by 2 plus 3. This is the distance. Therefore, I am substituting W value. I have found the RB value. 11.25 is the RB value. Now substituting in equation 1. Substituting in equation 1, 11.25. Therefore, I am getting RA value as 3.75. 3.75. So after finding RA and RB, I need to go for the procedure shear force diagram. Shear force diagram. So here we need to consider 3 points A, B and C. So beginning of the UDL need to be considered 1 point and ending of the UDL need to be considered another point. Again, at the same point we have a reaction force RB. Therefore, we have only 3 points B, C and A. Therefore, before B, so I need to consider the section before B. So there is no force on my right hand side of my section. Therefore, it is 0 kilonewton. At B, the section is at B now. Therefore, I need to consider point load which is moving upward direction. I need to consider the point load which is moving upward direction, whose magnitude is 11.25. Whose magnitude is 11.25. Therefore, 11.25 upward direction. Positive. We are getting a positive value. Next, C point. I need to shift for the C point. So before C. So here, before C means I need to have 2 point loads. One is RB and the second one is a UDL. Second one is a UDL. I need to convert the UDL into point load again, whose magnitude is 5 into 3. Whose magnitude is 5 into 3. Therefore, I am getting the 11.25 is a positive which is moving upward direction and a minus 5 into 3 which is moving downwards. Therefore, I consider it as a negative. Therefore, the net is 3.75 kilonewton. A negative. Next, yet to see, the same value here, small clarification before and yet. Before and yet having the same value if there is no external point loads. If any point having a point load, we need to consider the before and at. Otherwise, it having the same magnitude. So here C has no point loads. Therefore, directly whatever the value, I have considered that same value. If a point load is existing at C, I need to consider that point load. Next, shear force before A. Next point I need to shift for the A. Shear force before A. So here the right hand side forces are RB and a point loads only. So RB value is 11.25 which is moving upward direction and 3 into 5 which is moving downward direction. The same value will be existing. So if you see here a point load of RA which is moving upwards. Therefore, I need to find at A also. Before at need to be considered whenever the point load is acting at that location. Otherwise, no need of finding both. Directly we can go for the at. Next. So if I consider this RA value also, it is a point 3.75 which is moving upward direction. So it is a positive. Therefore, the net value is 0. The net value is 0. Using these values, Using these values, I need to draw the shear force diagram. Using these values, I need to draw the shear force diagram. So initially it is 0. Before B it is 0. At B it is a positive 11.25. So positive direction I need to consider it. Upwards. Above the baseline. Above the baseline. Next. Before and at. Before and at. We are getting a minus 3.75. Therefore I need to move downward direction. I need to move downward direction. So before A has the same value of minus 3.75 and at A it is 0. Now join. All these points. Join all these points. So a vertical line exists wherever vertical load will be wherever the point load is existing. So I am getting this type of a graph. This type of a graph. So if you observe this, if you observe this, the sign change. The sign change. The sign change is occurring here. The sign change is occurring here. Therefore, I need the location. I need the location. Therefore, I am considering this as a E point. So A, B, C, next D or E. Any point I need to consider here. I can consider as a D or E. Any point you need to consider here. So I am considering a E section here. The section at E. The section at E.
అదే ఆ రెండును వేరే వాళ్ళకి ఇచ్చాం తల్లి పిల్ల.
ఇది ఉంది కదా మళ్ళీ ఇంకోటి వాడుకోవడమే.
మేప్తే ఇచ్చారా?
అమ్మ ఎక్కడికి బయలుదేరుతుంది?
హలో
ఏమంటేగా
అంటే మీరు ఇలాగ వేసుకుంటారు స్థలం కొనుక్కుని ఎక్కడైనా
వేరే చోట పోసుకొచ్చారు.
అదే గొట్టుల మీద ఉంటది అలాగా.
So here I need to find out the E value, that is the location of the E from B. So I need the distance between E to B. I need to distance between E to B. E to B I need the distance. So I am considering the section at E. I am considering the section at E. The right hand side of my section. The right hand side of my section, we have two forces, that is RB, which is moving upward direction, and a UDL whose magnitude is 5 kilonewton per meter, and the distance is unknown. Therefore I need to convert this into point load whose point load is 5 into X. 5 into X. Therefore, I have only 2 point loads, first one and a second one. Therefore, from the graph, I am observing it is touching the baseline. From the graph, I have observed that it is touching the baseline. Therefore, shear force at E is equal to 0, which is equal by analytical, that is nothing but 11.25 is moving upward direction and 5 into X is moving downward direction. Therefore, a negative. It need to be 0. Therefore, substituting the values, X is equal to the distance between B to E is 2.25 meters. We have found it. Why we need to find here? So from the previous, that if the sign changes from positive to negative or negative to positive in the shear force diagram, at that location only we are getting a maximum bending moment. Bending moment maximum will occur at E only. The maximum bending moment will be occur at E only. Next, I need to draw the bending moment diagram. I need to draw the bending moment diagram. So here, while drawing the bending moment diagram, I need to consider each and every point. So here I have 4 points. First point, now the E is also existing. 4 points are existing now. E also existing. Therefore, first point is B, bending moment at B, the point load and its perpendicular distance from the section. The point load and the perpendicular distance from the section is at B only. There has no perpendicular distance. There has no perpendicular distance. Now, I need to shift the point, that is the section, at E. Therefore, at E now, it is also maximum bending moment because the sign changes at E. Therefore, the distance here is B to E is 2.25 meters. We have found it. Therefore, first point load is 11.25. First point load is 11.25 and its distance from the E. Its distance from E is 2.25 meters. Next, I have a UDL. I have a UDL on the top of the beam, whose distance is again 2.25 only. Therefore, I need to convert this UDL into point load, whose magnitude is 5 into 2.25. 5 into 2.25 is the magnitude. That is the capital W, is a point load. And next, I need the distance. I need the distance from the E. This distance. I need this distance. So the point load will be equally applied. That is, equal distance will be applied. Therefore, the distance is here 2.25. So 2.25 divided by 2 from the E. This is the distance from the point load. Therefore, I am getting a positive because due to this load, a clockwise occurring, and due to this load, an anti-clockwise is occurring. Therefore, this is a positive value. Anti-clockwise I have considered as a positive, and a clockwise I have considered as a negative. Therefore, the total value, the net value, is nothing but 12.66 kilonewton meter. Here, this is kilonewton and this meter. Therefore, kilonewton meter is the units, which is a positive value. So at the E is completed. Now next point is C. So I need to find out the bending moment at the C. So here the forces are RB, that is the first one, into the distance from C. From C, the force point load from C is a 3 meters distance. Therefore, 3 meters distance. Next, a UDL, total UDL need to be considered here, Amma, from C to B. Total UDL need to be considered. Therefore, the UDL length is 5 into 3. That is the point load converted UDL. And the distance from C is 3 by 2. Therefore, substituting all the values, I am getting a positive 11.25 kilonewton meter. Next point, after C, I have an A. I have a point. Therefore, the point load is 11.25 and distance from A is nothing but 6 meters. It is 6 meters. I need the distance from A of this point load. It is 6 meters. Next, I have converted this UDL into point load and I need the distance from A. I need the distance from A to this point load. So it is nothing but 5, that is 3 by 2, that is center, 3 by 2, and next this 3. That gives the total distance from this point load. And another point load is RA into distances. It is passing from A, therefore the distance is 0. So I will get the 0 as a bending moment. Now using this, I need to draw the bending moment diagram. Using this, I need to draw the bending moment diagram under the shear force diagram. So here I am getting a 0 initially and 12.66 and next 11.25 and 0. 4 points I am getting and 4 points I need to join. So if you observe here, in between B and C, a UDL is existing. Therefore, I need to join by a free hand. So up to C, I need to join by a free hand. Next, in between A and C, a point loads are acting. Therefore, I need to join by a straight line. I need to join these 2 points by a scale. So totally I am getting a positive bending moment diagram. Totally I am getting a positive bending moment diagram. So a similar problem, please read the problem once. A simply supported beam 5 meters long is loaded with a uniformly distributed load of 10 kilonewton per meter over a length of 2 meters. A UDL is acting only 2 meters. So but the length of the beam is 5 meters. But in this problem, he had given the diagram. Otherwise, we need to draw the diagram. So, he had given the diagram. So, here, initially 2 RA and RB are the reaction forces because both ends have two supports. Simply support means the beam ends have two supports. And next, UDL beginning 1 point and UDL ending 1 point need to be considered. So total I have 4 points, A, B, C, D. A, B, C and D. Now I need to find out the two unknowns RA and RB initially to draw the bending moment diagram and shear force diagram. Initially I need to find out the reaction forces RA and RB. So here I need to convert the UDL into point load. I need to convert the UDL into point load of capital W. Therefore, here the magnitude is 10 and the distance is 2. Therefore, 10 into 2 is the point load. 10 into 2 is the point load I can apply, and I can remove the UDL now. I can remove the UDL now. Now, only 3 point loads RA, RB and W are existing as shown in the figure. RA, RB and W. And I need the distance from A and distance from B also. I need the distance of this point load. So I am considering this distance as 2 by 2 and this is also 2 by 2 because the point load will be acted at the center of the distance. Center of the distance. So now from A, the point load is 1 plus 2 by 2 is again 1. Therefore, I am getting 3, that is 2 meters from A. This point load is at a distance of 2 meters from A. And the same point load is at a distance of 3 meters from B. From B, the point load is having a distance of, this is 1 and this 2. Therefore, the total distance is 3. Now, a point loads are and its distance are known values now. I need to find out the unknowns RA and RB. I need to find out the unknowns RA and RB. Therefore, RA plus RB is equal to, which are moving forces upwards, and it need to be balanced by the moving forces downwards. Therefore, W is nothing but 10 into 2. That is the first equation, equilibrium condition. And the second equilibrium condition is considering the section at A. Considering the section at A, the forces and its perpendicular distance from A. Therefore, this is the first force, this is the second force. So, first force is RB into perpendicular distance is 5 from A. From A, the perpendicular distance is 5. The perpendicular distance is 5. And due to this force, anti-clockwise direction is occurring. Therefore, it is a positive. Next second force is W. Next second force is a W, whose is 10 into 2. And the distance from A, I need the distance from A is 2 meters. That is 2 by 2. It is again 1 plus 1. It is nothing but 2 meters. Therefore, substituting, I am finding the RB value as 8 kilonewtons and substituting the RB value in the equation 1, RA is equal to 12 kilonewtons. Next, I need to draw the shear force diagram. So here, from the right hand side to left hand side, I am moving the section. I am moving the section from the right hand side to the left hand side. Therefore, the first point is a B. So at the B, we have a point load. Therefore, I need to consider the before and at. Before and at. Therefore, before B is 0. At B is 8 kilonewtons, which is moving upwards. It is a positive. Next, if I consider the second point is D, there is no point load at D. There is no point load at D. Therefore, directly I can take it as at D. No need of considering the before D. The same, we will get the same values. We will get the same values. We will get the same values. And next, shear force before C. Before C. So here the section is now at this location. So we have two forces, RB and a converted UDL. A converted UDL whose magnitude is W into 2. That is 10 into 2. So I am getting 12 a negative kilonewton. Net is at 12 negative kilonewton. And at C also there is no point load. Therefore, I will get the same value. And last point is A. So before A, the same value. Now the section is before A, the same value in my right hand side of my section. Therefore, a minus 12 kilonewtons. At A, a positive 12 kilonewtons is upwards force is applied here. A positive 12 kilonewtons upward force is applied here. Therefore, the net is a 0 shear force. 0 shear force. Using these values, I need to draw the shear force diagram under the beam. So 0, a positive 8, a positive 8, and a negative 12, and a negative 12, and 0. Now I need to join here. So joining all these points, I will get a graph like this. It is changing its sign. Again, it is changing its sign from positive to negative at some location. I don't know that location. So I have completed A, B, C, D points. Therefore, I am considering the E point at that location. I am considered as E point at that location. Now, considering the E section. The section is at E. Therefore, the right hand side forces R, RB, and UDL need to be converted here into point load. Whose magnitude is 10 into X, unknown value. This distance is not known now. And it is at a distance of, again, X by 2. It is at a distance of X by 2. Now I am considering only shear force. Therefore, only forces need to be considered here. RB moving upwards is a positive, and capital W is a moving downwards. Therefore, 10 into X. Therefore, X is equal to 0.8. Therefore, from D, it is 0.8 m-meter. From D is at a distance of 0.8 meters from D. E is at a distance of 0.8 from the D. So we have now 1, 2, 3, 4, and 5 points. 1, 2, 3, 4, and 5 points. So I need to find out the bending moments at 5 different points. I need to find out the bending moments at 5 different points. Therefore, the bending moments are, so first point is B. Since I am moving from the right hand side to the left hand side, I'm moving from the right hand side to the left hand side. The section is moving from the right hand side to the left hand side. The first point is B. Therefore, 8 into the perpendicular distance is 0 because the section is at B. RB into 0. Next, the section is at D now. The section is at D. The right hand side forces are RB and its perpendicular distance from this section. The section is at D now. From the D to RB, what is the distance? Therefore, it is 2 meters. Therefore, 8 into 2. And due to this load, it is anti-clockwise direction, so it is a positive. Therefore, a positive 16 kilonewton meter is getting here value. Next point is, third point is at E. Third point is at E. So bending moment at E, we are getting a maximum bending moment. Therefore, the two forces are available here. One is RB and another is the UDL converted on my right hand side of E. The UDL converted on my right hand side of E. That is capital W is 10 into X. This is the X value from D to E, whose value is 0.8. Therefore, I need the distance from E to this point load. Therefore, from D to B, I know it is a 2, and from D to E, it is 0.8. Therefore, the total distance is 8 into 8 is the force amount. 8 is the force applied RB, and the distance is from E is 0.8 plus 2. So I am getting 2 plus 0.8 as a distance. Next, another point load is a capital W. Capital W 10 into 0.8 is the point load on my right hand side of my section, and the distance of this point load is X by 2. X by 2. Therefore, I am getting 0.8 by 2. So the net is a positive 19.2 kilonewton meter. A positive 19.2 kilonewton meter. And next point, I need shift for C. The bending moment at C means the section is at C now. The section is at C now. The forces on my right hand side is RB and a total UDL. A total UDL. Therefore, RB and its distance from C. From C, I need from C the distance. So it is 2 and 2. So I am getting 4. 2 plus 2. I am getting from C to B distance is 4 distance. 8 kilonewton having a distance from C is 4 kilonewton, 4 meters. Next, the UDL converted point load, that is 10 into 2 meters now. 10 into 2 meters. So the total length need to be considered here. Because I am considering the section at C, the total UDL is to be considered. Therefore, 10 into 2 is the point load, and the distance from the C is 2 by 2. The distance from the C is 2 by 2. Therefore, it is a positive 12 kilonewton meter. Next, last point is A. Last point is A. Therefore, my right hand side forces are RB, and its distance from A is 5 meters. Its distance from A is 5 meters, and a point load of a UDL is 10 into 2, and distance from A is 2 by 2 plus 1. This is the 1, and this is 2 by 2. This is 2 by 2. Therefore, I will get a 0. It need to be getting a 0 because initially we are considering the bending moment at A is equal to 0, and we have derived the unknowns RA and RB. If I am not getting the 0, then the problem is wrong. That is nothing but RA and RB values are not a correct values. If I am not getting the 0 at this location, ఈ పొజిషన్ లో నాకు 0 రాకపోతే గనక RA and RB are the wrong values you have calculated. It need to be 0 because I have considered it as 0 initially. 0 అనుకుని ప్రాబ్లం సాల్వ్ చేసామా, 0 రావాలి. రాకపోతే గనక మీరు RA and RB ఆర్ తప్పు చేశారు అని కన్ఫర్మ్ చేసుకోవచ్చు. So using this, I need to draw the shear force diagram and bending moment diagram. So initially it is a positive H. ఇదంతా ఆల్రెడీ షియర్ ఫోర్స్ డయాగ్రామ్ ఇంతకు ముందే గీసామా. బెండింగ్ మూమెంట్ డయాగ్రామ్ 0, 0, 16, 19.2 and 12. So if you observe here, the UDL is acting in between C and D. The UDL is acting in between C and D. Therefore, in between C and D only I need to join by a free hand. In between C and D only I need to join by the free hand. Remaining I need to join by a straight line. Remaining I need to join by a straight line. Wherever the UDL is existing, there only I need to join by a free hand. Other than that, I need to join by a straight line, by a scale. So I need to join these 2 points by using a scale and a pencil. Now, if you join all this, all are a positive values. Therefore, I am getting a positive bending moment diagram. Positive bending moment diagram. And a shear force diagram, if you see the shear force diagram, the sign conversion is available. Therefore, I need to find out the maximum bending moment. Maximum bending moment under the beam. So with this, the UDL on the beam is completed. The UDL on the beam is completed. Next problem, tomorrow problem, we will discuss about the beam having the UDL and a point load. Both loads, that is a point load and a UDL. A point load and a UDL exist on my beam. So a combination of UDL and point load. May exist on my beam. So how to solve this? We need to discuss. And last is, that is a varying load. Last one is a varying load. So here, next problem also a UDL and a point load. So here, 2 UDLs with the different magnitudes are applying. So we need to discuss this also. And last one is varying load. Varying load also need to be discussed. So with that, the simply supported beam will be closed. With that, the simply supported beam will be closed. Okay, Nama? So with this, I am closing the section.